So section 1.3 is measuring segments. Before we start this segment, we need to remember that when we're naming a segment, you're going to have your endpoints with the segment symbol above them. So this means naming them. But when we're talking about length, we're just going to have the letters like that with no symbol above them. And so this is something to keep in mind. When naming a segment, we use the line above. When talking about the length of the segment, we just use the two letters. All right, so first we have postulate 1.5, the ruler postulate. Every point on a line can be paired with a real number. It's a one-to-one correspondence. The real number that corresponds to a point is called the coordinate. So this is your definition for coordinate. The real number that corresponds to a point is called your coordinate. The distance between A and B is the absolute value of the difference of their coordinates. And so we're talking about distance on a number line. So distance is the absolute value of the difference of the coordinates, or in this case, the absolute value of A minus B. So let's say we have point A here and point B here. To find the distance between the two, we would take A minus B, or the absolute value of A minus B. And so this is going to equal your distance on a number line. Keep in mind there are two different types of distance. We're going to talk about number line distance and then coordinate plane distance later on. But for right now, we're talking about number line. So here they want us to find the distance or the length of ST. So we're going from S to T. So if we set this up, we're going to have the absolute value of -4 minus 8. So that's the absolute value of -12, which means our length is just 12. You could have also counted, but this is a little bit more mathematical. So the length of UV in this case, we're going from U to V, so we're taking the absolute value of 10 minus 14, which in this case is the absolute value of -4, which in this case is just 4. So UV has a length of 4. And then SV, we're going from S to V, so that's -4 minus 14. So the absolute value of that would be the absolute value of -18, which in this case is just 18. So SV is 18. Keep in mind your length should be positive. A segment is not going to have a negative length. You're not going to travel negative miles. So distance is usually done, and it actually is always done in positive increments. So we're looking at positive numbers. Postulate 1.6 is the segment addition postulate. If 3 points A, B, and C are collinear, and B is between A and C, then AB plus BC equals AC. So it's part plus part equals whole. We take the smaller part plus the other small part and put them together to get the whole length of the segment, in this case AC. So here we're using the segment addition postulate in order to find the measure of EF and FG, and we have to do this algebraically. So we know that EG, or the entire measurement, has a length of 59. But we also know that if we take this piece plus this piece, it should equal EG. So EF plus FG equals EG. So EF would be 8x minus 14 plus 4x plus 1 equals 59. We're going to combine like terms. So 8x and 4x becomes 12x. -14, positive 1 is -13. Equals 59. Algebraically, we'll add over the 13. We get 12x equals 72. We'll divide by 12, and in this case, x equals 6. We're not done yet, because they asked for the length of EF and FG. So to find the length of the two segments, we're going to plug it back into their respective equations. So for EF, we've got 8 times 6 minus 14 which in this case is going to give us 34. And then for FG, we've got 4 times 6 plus 1, which is going to give us 25. So EF is 34, FG is 25. This example is very, very similar to the last. They're telling us that JL, or the entire segment, has a length of 120, and we know that the part plus part should equal the whole. So right now we want to make sure we're taking JK plus KL is equal to JL. So go ahead and pause the video, work this one out on your own, and then check your answers after you're done. I'll give you a minute, and then when you unpause it, you should see the answers. So if you've done the work correctly, you will set up both expressions, add them together, and set equal to 120. Solving for x in this case, we get x to be 9. We then take x and plug it into the expressions for both segments, JK and KL. We should get that JK is 42 and KL is 78. Congruent segments. Congruent segments are segments that have the same or equal lengths. The symbol, the equal sign with the squiggly line, means congruence. All right, so the next part of this, it says, are segments AC and BD congruent? So basically, do AC and BD have the same length? So right now, AC from A to C, we should figure out that the length of AC is 7. You can either count that, or you can use the distance, number line distance formula. And then BD, well, from B to D, is also 7. So yes, they're congruent. They have the same length, so they're congruent. And we'd write this, so yes, AC is congruent to BD. And we need to make sure we write it with our symbols because we're talking about the congruent statement here. In the second question, are AB and DE congruent? Well, A to B has a length of 5, where DE in this case has a length of 3. So we can say no. In this case, AB, and we draw the congruent sign and we put a line through it, is not congruent to DE. A midpoint. A midpoint is a point that divides a segment into two congruent segments. So let's say we have A, and then we have B here, and we have this point in the middle and we call it M. Well, if M is the midpoint, then that means that AM is congruent to MB. These little marks here that I made they're like little dash marks or hash marks. They mean congruent. So this line is congruent to this line because they both have two of the little lines through them. Segment bisector. A point, line, ray, or other segment that intersects a segment at its midpoint is said to bisect it. So bisect means to cut in half. So when something bisects it, it cuts it into two equal parts. So once again, if we have points A, we have points B, and then we've got the line between them. Let's say we have a ray cutting through here. If we create congruent parts here and here, and this is our midpoint M, this ray is acting as the segment bisector. It's cutting the segment into two equal parts. So here, if Q is the midpoint of PR, so right now we know that PQ is congruent to QR. In this case, we can use 1 dash or 2 dashes per side, but I'm going to use 1 in this case now. So Q is the midpoint, so it's cutting P, it's making PQ equal to QR. And we know that PQ has the equation of 6x minus 7, and QR is 5x plus 1. Find the measures of PR, PQ, and QR. Well, in the previous examples, they gave us the length of PR, but here they do not. So we've got to find another way to solve for x. Well, the key here is the word midpoint. Midpoint means that Q is cutting PR into 2 equal parts. So if these 2 segments are congruent, I can set their expressions equal to each other because I know that PQ equals QR. So in this case, I'll do 6x minus 7 equals 5x plus 1. And then I'll just solve for x. So I'll bring the 5x over through subtraction. I get x. I'll add the 7 over, and I get 8. So x equals 8. To find PR, PQ, and QR, I'm just going to plug the 8 back into the 2 expressions and see what I get. So let's start with PQ. We've got 6 times 8 minus 7. Well, in this case, I get 41. QR, I'm going to take 6, or not 6, we'll take 5 times 8 plus 1, which gives me 41 as well. And then to find PR, I can add the 2 segments together, and in that case, I get 82. So the length of PQ is 41, QR is 41, and PR is 82. Here we have an example that's almost identical. They're telling us that U is the midpoint of TV, so it's creating a congruent segment here and here. So that means these 2 should be equal to one another. So in order to solve this, we have to recognize that TU equals UV. So go ahead and solve this like we did the previous problem. Once you know what X is, plug it back in to find the lengths of TU, UV, and TV. When you're ready to see the answer, unpause the video and check your work. So, if you've done this correctly, you would have taken 8x plus 11 equals 12x minus 1. When solving it algebraically, you get x to equal 3. Plugging 3 back into TU's expression, you get 35. Plugging it back into UV's expression, you get 35. And then adding the 2 together, you get TV has a length of 70.